So I'm going to do recording for problems 3, 4, and 16 from week 13. Quite a few people have asked me about number 3, and I think it's probably because of the difficulty in drawing the picture for this one. If you don't get the picture right, then you can't figure out the problem. So on this one, what we've got is the 2 ranger stations. It says they're on an east-west line. And then it tells you down here that this western station is at A and the eastern station is at B. So that means that A is the one to the west and B is the one to the east. So I'm going to put A here. I'm going to put A here and B over here. And then it tells you that they're 110 miles apart. So now we want to do the location of the fire from each of the 2 stations. So from station A, it's a bearing of north 42 degrees east, which means starting at A, we're going to go due north. From due north, we're going 42 degrees to the east. So that would be 42 degrees this way. So that means that we want to draw a 42-degree angle in here and then just draw the line that goes along that. So if this is 42 degrees, and our line here is going straight out this way. So the forest fire is somewhere along that line. Then from the station at B, it's north 15 degrees east. So we want to do the same thing. We want to think of due north and then go 15 degrees to the east of that. So this is going to make this a pretty small angle if this is only 15 degrees. So that means our forest fire is going to be out along this line. And what we actually end up with is the forest fire is at the point where those 2 angle lines intersect. So that's where our fire is. Okay, now that we have the picture, what we're trying to find from this is how far the fire is from the western station. In other words, how far it is from station A. So I'm going to name the sides of this triangle with the points that we already have. So I'm going to call this angle A. I'm going to call this angle B right here. And that means that the side over here would be side A and the side over here would be side B. And then if we wanted to, we could call this angle C and call this side C. And that means what we're trying to find in this problem is the length of side B. All right, so to do that, what we need is to define our triangle. We've got these angles that are not exactly the angles of the triangle, but we can find these 2 angles with what we've got here. For this one, because this is a right triangle from here to here, that means these 2 angles are complementary. We have to add up to 90 degrees, and that would make this angle 48 degrees. So that's our angle A. For this one, we've got a right angle right here. So this entire angle is 90 degrees plus another 15. And that makes our angle B 105 degrees. Now that we've got 2 of the angles in the triangle, we can find the third one. If we take 48 plus 105, that adds up to 153. So to get our third angle, we're going to subtract 153 from 180. And that gives us 27 degrees. So that angle up there is 27 degrees. Since we have side C, the reason we needed this angle is that now we have an angle and the side across from it. That means that we can use the law of sines. We always want to try and use the law of sines if we can, because it's easier to apply than the law of cosines. So from the law of sines, we would have side C over the sine of angle C. And what we're trying to find is this side. So we want to do side B over the sine of B. And B was 105 degrees. That's the setup for our equation. Now we want to cross multiply. That's going to give us 110 times the sine of 105 equals B times the sine of 27. To solve this for B, we're going to divide both sides by the sine of 27. And so I'm just going to do this all at once in my calculator. And I'm making sure I have this changed to degree mode. Okay, so that's going to give me that B is 234 miles approximately. And in this problem, it said to round to the nearest 10 miles. So that means the distance from station A to the fire we're going to round this to 230 miles. Okay, then let's look at number 4. So this one is also doing bearings, but it's doing the other kind of bearings where you just have an angle. And so for that, it starts from due north and goes clockwise for this kind of bearings. In the first position that the ship was in, the bearing of the lighthouse from the ship was 308 degrees. So if I draw that, here's my position 1 for the ship. And if my bearing is 308 degrees, I'm starting from due north and going clockwise 308 degrees, which is going to put me over here somewhere. So again, I'm going to draw this line out because what I know is that the lighthouse is somewhere on that line. So this angle all the way from here around to here is 308 degrees. After that, the ship sails 5.8 kilometers to the south. So it's going to go down to here someplace. This distance from here to here is going to be 5.8 kilometers. And at this position, the bearing of the lighthouse from the ship is 337 degrees. So I'm going to do the same thing again from here. I'm going to start from due north, which would be up here, and go around 337 degrees, which is going to put me somewhere over there. Okay, so that means the lighthouse is somewhere along this line. And this angle is 337 degrees. So where the lighthouse actually is where these intersect, which would be right there. What we're trying to find in this problem is the distance from the ship to the lighthouse at each of the 2 locations. So we're trying to find this side, and we're also trying to find this distance. So I'm just going to name my sides. I'm going to call this side A because I'm looking at this triangle right here. I'm going to call this side B, and I'm going to call this side C. So I have enough information to find this angle of the triangle and this angle of the triangle. If I can find those 2 angles, then I can find the 3rd angle, and that will give me an angle with the side across from it, which means I can use the law of sines. So let's look for this angle first. If this complete angle from here across to here is 308, from here down to here would be 180. So to get this from here to here, I would take 308 and subtract 180 degrees. And that gives me 128 degrees. So that is my angle B. To find this angle in here, I know this 337. If I went the rest of the way around the circle, that would give me this angle. So that would be a total of 360 degrees. So to find that little angle, I'm going to take 360 and subtract 337. And that gives me 23 degrees. So that is going to be my angle A. Now that I have these 2, I can find angle C, which is going to be this one over here. So I'm going to take these 2, add them together. So that's 151. And then subtract that from 180, which is going to give me 29 degrees for angle C. So this one up here is 29 degrees. Now, since I want to find both A and B, I can find just one at a time. So I'm going to start by finding side A. So I'm going to do A over the sine of angle A, which was 23 degrees. And then for the other part, I'm going to use the side and the angle that I know both measures for. So side C is 5.8, angle C is 29. And then I'm just going to solve this for A. Actually, all I have to do for this is multiply both sides by sine of 23. Okay, so this gives me, and this is telling me to round to the nearest tenth of a kilometer. So this is going to give me 4.7 kilometers. Then I'm going to do the same thing to find side B. So my angle B was 128. That gives me B over the sine of 128. And I'm going to use the same thing on this side of the equation. That was C and the sine of C. So then to solve this for B, I just have to multiply on both sides by the sine of 128. And if I round that to one decimal place, I get 9.4 kilometers.